So in section P2, we'll be continuing with more basic rules of algebra. So we'll start with some terminology. So for the first little definition here, we have terms. So the terms of an algebraic expression are going to be the parts that are separated by addition. The coefficient of an expression is going to be the numerical part of a term. A constant term is going to be a term that only has a number, so no variable. Factors of a term are going to be parts of the term that are being multiplied together. So we should already know that from previous sections what a factor is. And lastly, like terms are going to be terms that have exactly the same variable factors, which we'll get into in a little bit. So for example, let's say we have this algebraic expression x squared plus 4x plus 5 plus 7x minus 2x squared. And we're going to use that to answer these questions. So for this first one, how many terms are there in this expression? So the terms are separated by addition. So it's going to be 1, 2, 3, 4, and 5. So there are 5 terms in this expression. The coefficient of the first term, so the first term is x squared. There is a coefficient of 1 whenever nothing is written, so the coefficient is 1. The coefficient on the last term, so the last term is negative 2x squared, so that means the coefficient is going to be negative 2. The constant term here is going to be the term with just a number, so no variable factor, so that's going to be the 5 in the middle. And the like terms in the expression, so the like terms, so remember from right up here, like terms have the same variable factors. So it's going to be the same variables with the same number of, with the same exponent. So that's going to be x squared and negative 2x squared are like terms because they both have an x squared variable factor. And then we also have 4x and 7x are like terms because they both have a variable factor of just x. And lastly here are the factors of the second term. So the second term is 4x. So the factors are what's being multiplied together. So that means the factors are just 4 and x. Okay, so it's a really important terminology that we'll be just kind of using throughout the course here. So now we're going to go over about 5 properties, starting with the commutative property. So the commutative property, there's 2 of them. Commutative property of addition is the first one. So these are all going to seem pretty obvious. Commutative property of addition is essentially if we are adding 2 numbers, the order doesn't matter in which we add them. So we have a plus b equals b plus a. So we probably know that's true. Because if we have something like 2 plus 7, we know that equals 7 plus 2, because they both equal 9. So pretty obvious. The next one, the commutative property of multiplication. So similar idea here, that order doesn't matter. This time we're multiplying, so we're multiplying 2 terms and the order does not matter. So that means a times b equals b times a, which we know is true because 3 times 4 equals 4 times 3. They both equal 12. So we kind of take these rules for granted because they seem kind of obvious. They always hold for numbers. They don't hold for other things in math, which maybe you'll get on later in your math career. So let's do some examples using these properties. So let's use the commutative properties to rewrite an equivalent algebraic expression. So for the first one, for y plus 6, so this is going to be addition. So the commutative property of addition says order doesn't matter. So this is the same as 6 plus y. Okay, and then we have for b, we have 5x. So that is 5 times x. So the same thing using the commutative property of multiplication would be x times 5. So we're never really going to write it like that, x times 5. It's always just going to be 5x because it looks better, but they mean the same exact thing. Lastly, 13x plus 8. So let's use the commutative property of addition and make it 8 plus 13x. So I'm going to use the multiplication, the commutative property of multiplication for that second term and make this 8 plus x times 13. Okay, so these all mean the same exact thing. And the next properties, so that's the commutative properties. The next ones are the associative properties. So once again, we have one of addition, one of multiplication. So the associative property of addition looks pretty similar probably to the commutative property. This time it's going to be with 3 terms. So essentially it's saying the order doesn't matter when we're adding with 3 terms. So we have a plus b plus c equals a plus the b plus c added first. So remember, order of operations, you have to do the parentheses first. So the left side is saying we're doing the a plus b first. Second side is saying we're doing the b plus c first. So for example, let's say we had 2 plus 3 plus 4. This is the same as 2 plus, then the 3 plus 4 first. So order of operations, 2 plus 3, so on the left first, would be 5, and then plus the 4. We're saying it's the same thing as 2 plus 3 plus the 4 is 7. Both of these equal 9. So the order doesn't matter with 3 of them. For the associative property of multiplication, same concept. Order doesn't matter with 3 terms being multiplied. So if we multiply a times b first and then by c, it's the same if we multiply b times c and then by a. So that would be something like 2 times 3 times 4 is going to be the same as 3 times 4. So on the left-hand side, 2 times 3, parentheses first, we get 6. Right side, parentheses first, we get 3 times 4 is 12. 6 times 4 we know is 24, and so is 2 times 12. So let's use these properties to help us simplify expressions, because that's what we will be doing. So we have 3 plus 8 plus x. So the 8 plus x is implied that it's being added first. Thanks to the associative property of addition, this is the same as 3 plus 8 and then the x, which is 11 plus x. So we obviously won't be rewriting that intermediate step, but that's technically why we're allowed to do it. Last one here, we have 8 times 4x, where the 4x is being multiplied first. Based on the associative property of multiplication, that's the same as 8 times 4 and then by the x. So 8 times 4 is 32. So this is just 32x. So those are probably pretty obvious. For the next one, which may not be as obvious, but it's very, very important, is the distributive property. The distributive property tells us that multiplication distributes over addition. So if we have these parentheses here, b plus e plus d plus whatever, so there's a bunch of terms being added together, and they're inside parentheses, and we have this a being multiplied out front. What that means is that we're going to distribute the a into every term inside of here, and it's going to get multiplied by every term. So it becomes a times b plus a times c plus a times d, and so on for however many terms are in there. Okay, so let's do some examples here. So let's multiply and simplify. So for the first one, we have 6 times x plus 4. So we're going to distribute the 6 to both of these terms. I'm going to draw some arrows just to help us see what we're doing. So it's going to be 6 times x plus 6 times 4. So that gives us 6x plus 24. And that's our simplified answer. Next one, we have 5 times 3y plus 7. So once again, we're going to distribute that 5 being multiplied out front. So we're going to multiply both of those terms by 5. It becomes, so I'm not going to write an intermediate step. I'm just going to skip to the answer here. 5 times 3y is 15y, plus 5 times 7 is 35. Okay, and then for the next one, 4 times z minus 3. So distribute that 4 in there, so it gets 4 times z minus 4 times 3, so minus 12. And for the next one, we have a times 2 plus 5b minus c. So we have 3 terms in parentheses here, which is fine. We're going to do it the same way, except we're going to multiply it to all 3 of them. So it's going to be a times 2. So always write that coefficient first, so make it 2 times a, plus a times 5b. So instead of writing a times 5b, and instead of writing 5ba, I'm going to write this as 5ab. So the coefficient should be first, and then everything else, the variables after that, should be in alphabetical order. It's just a nice and organized way of doing it. Lastly, it's going to be multiplied to that c, so minus a times c. Okay, so pretty much as simple as that. Last one here, we have 2 plus y minus z times x. So it looks a little bit different because that one term is on the right. We're going to do the same exact thing, except before we do that, I'm going to rewrite it like this. So we can rewrite it with x times those terms in parentheses based on the commutative property of multiplication. You don't have to write it like that though. And then we can see that we distribute it to all of these terms. So it's going to be 2x plus xy minus xz. Okay, so that's pretty much it for distributing. It's relatively simple, but very, very important. So we're going to be using all of those properties to help us simplify expressions. So we're going to do that by combining like terms. And as we mentioned on the first page, like terms are terms that have the exact same variable factors, which means they have the same variables with the same exponents on those factors. So technically, when we're combining like terms, we're using the distributive property, except we're doing it in reverse, essentially. So if we have 2 terms, ax plus bx, those are like terms. If we're combining them, we're going to add a and b and then multiply by x. So that would be the distributive property in reverse, because we'd be multiplying this x into both of those terms. We're not always going to think about it like that, but that's how I'll start it off. So let's combine these like terms. So we have 4x plus 15x. So probably we know that right away this is going to be 19x because 4 plus 15 is 19. Technically what we're doing is the distributive property in reverse, which is actually called factoring out an x here. So what we're going to have is 4 plus 15 and then times x. So we get 19x. So you never have to write that intermediate step. I won't ever do it ever again after these examples. But that's technically what we're doing. So next one, we have 7a minus 2a. Once again, we probably know that it's 5a because 7 minus 2. Technically what we're doing is saying that's 7 minus 2 and then times a. 7 minus 2, 5, so 5 times a. Okay, and then when we have 3 or more terms in a expression, we're actually going to be using the commutative and associative properties to group like terms. Once again, you don't have to think of it this way, but that's just technically why we're able to do this. So let's start by simplifying by combining like terms. So first one, we have 7x plus 5 plus 3x plus 8. So I'm going to reorder these as 7x plus 3x plus 5 plus 8. So the only reason I did that was just to show that technically this is using the properties, the associative properties for addition. So now we can combine 7x plus 3x is 10x, 5 plus 8, 13. So 10x plus 13. And then for this next one, 4x plus 7y plus 2x plus 3y. I'm just going to rewrite it by grouping the terms. So 4x plus 2x plus 7y plus 3y. So this is the same thing as this. Thanks to the commutative and associative properties of addition. Combined like terms, we get 6x plus 10y. Okay, so that's going to bring us to some harder examples here. So in general, simplifying algebraic expressions, what this means is that when the parentheses are completely gone and like terms have been combined. So that's what it means to be simplified in this case so far. So for the first example, we have 5 times 3x plus 7 plus 6x. So for all of these, what we're going to have to do is pretty much distribute and then combine like terms. So first we have to distribute this 5. So distributing that 5 is going to get us 15x plus 35, and then plus that 6x. So next, the like term is probably pretty obvious. We have an x to two x terms. So we could rewrite it with the x's next to each other. I'm just going to skip that for now. 15x plus 6x is 21x, so 21x plus 35, and that's our simplified expression. Okay, next one we have 8x plus 2x, and then in parentheses, 5 minus x minus 3. Actually, I'm going to erase this x right here. That's not supposed to be there yet. And I will get into why that's not supposed to be there yet, because we didn't learn how to do that one yet. Okay, so now we're doing this one, and first what we're going to do is I'm going to do inside the bracket, and I'm going to distribute this negative first. So we're going to have 8x plus 2 times 5. Distributing the negative, we get negative x plus 3. So we have the negative, essentially we're distributing a negative 1, essentially. So negative 1 times negative 3 is positive 3. So let's combine like terms inside that bracket. So remember, a bracket is just parentheses. So we have 5 plus 3, which is 8. So 8 minus x. Now I'm going to distribute this 2. So it's going to be 8x plus 16 minus 2x. Combine 8x minus 2x, we get 6x. So 6x plus 16. Okay, and then let's see, a couple more here. I'll do 3 more to make them a little bit harder. So we have 6 times 2x plus 4y plus 10 times 4x plus 3y. So we can distribute, or we have to distribute this 6, and we're going to have to distribute this 10. So distributing that 6 is going to give us 12x plus 24y. Distributing the 10 gives us 40x plus 30y. Combining like terms, we have an x term and a y term. So 12x plus 40x is going to be 52x. 24y plus 30y gives us 54y. And for second last one here, we have even more confusing. We have negative times 3x squared minus 4x plus 3 times x minus y plus 2x squared minus 5y. Okay, so for this one, we're going to distribute this negative. So what that means is we're distributing a negative 1. And then we're going to distribute this 3 to all of these 3 terms in here. So distributing that negative is going to just negate everything. So negative 3x squared plus 4x. Distributing the 3 becomes plus 3x minus 3y. Plus 3 times 2x squared is 6x squared. Minus that 5y. So combining like terms, we have 3 different terms here with different variable factors. We have x squared term, we have an x term, and we have a y term. So let's combine the x squared terms. So negative 3x squared plus 6x squared, negative 3 plus 6 is 3, so 3x squared. 4x plus 3x is plus 7x. And then negative 3y minus 5y is negative 8y. So that's our final simplified version. And the last one here, we have 3 times a squared plus 4a squared times b minus ab squared plus a squared minus 6 times a squared b minus ab squared. So a bunch of distributing going on here. Distribute the 3. Oops, just say those 2 terms. We're going to distribute a negative 1 again, and then we're going to distribute a negative 6. So distributing the 3, we're going to get 3a squared plus 12a squared b. Distributing the negative 1 is going to be minus ab squared minus a squared. And then lastly, distributing that negative 6, that's negative 6a squared b. Negative times a negative for the last term, positive 6ab squared. So you just have to be careful with the negatives, obviously, when you're multiplying. So combining like terms where it gets a little bit tricky. So we have I'm going to underline them. We have 3a squared, and then we have a minus a squared. So combining those is going to give us 2a squared. So remember, there's a coefficient of 1 if nothing's written, so that's 3 minus 1. Next, we have a squared b term. We have another a squared b term right here, so we're combining those. So remember, same variables with the same variable factors, which means same exponents. 12 minus 6 is 6, so plus 6 a squared b. And lastly, we have minus ab squared plus 6ab squared. Like terms, negative 1 plus 6 is plus 5ab squared. Okay, so that is it for section P2.